To begin with, we formally define what it means for a function to be a polynomial with a definition before you. While this definition can look quite complicated, I assure you we've already seen polynomials before. For example, the linear function is a polynomial. Also, the quadratic function is a polynomial. In this video, we'll be specifically focusing on the quadratic function. First of all, formally speaking, a quadratic function is a second-degree polynomial function whose graph is known as a parabola. Let's take a look at a basic parabola, one where we only have ax squared, and a is a positive number. This graph in orange represents the graph of ax squared. Please take a moment, pause the video, and copy down the following information, as well as inspect the graph and convince yourself that the information given is correct. It is important to note that if the leading coefficient of a quadratic function is positive, the graph will open upward. What if the leading coefficient were not positive? Once more, take a moment to inspect the graph. Also, copy down the information given with this graph. If a quadratic function has a leading coefficient which is negative, the graph will open downward. In both cases, the parabola is symmetric around a particular line. This line is known as the axis. If you were to fold a parabola over its axis, it would exactly match up, point for point. Where the axis meets the parabola is called the vertex. We are usually quite interested in the vertex of a parabola, as it is always a maximum or minimum of the function. We even have a special form called the standard form or the quadratic vertex form. Here is the standard or vertex form of a quadratic function. What's so awesome about the quadratic vertex form? Well, we immediately know where the vertex is just by looking at the equation. The vertex is always at h, k.